Welcome back to My Smart Learning. We are doing a physics lesson today on gravitational potential energy. It's for my year 9 lessons that are missing classes this week, but it's useful for year 7s because we started to push the year 7s ahead. But you need it for year 9, year 10, year 11. It's revision for your questions on gravitational potential energy for your GCSE science and your GCSE physics. So obviously, we like to start with the joke of the day because you all have a moan about how bad my jokes are. So we will see how good today's joke is. Alexa, tell us a joke.
How is duct tape like the Force? It has a dark side, a light side, and it binds the galaxy together.
There you go. You like that science joke, and it was probably actually a bit better than mine, but anyhow. Right, so gravitational potential energy, what is it? Well, we talked, that's our learning objective. What is GPE and what does it depend on and how do I calculate it? So that's your objectives for today. Now, quick recall PT. I keep mentioning it towards the end of the video. Some of you are not watching the videos to the end. I know I'm boring half of you to death, but can you make sure that you use your revision guide to make the notes? Because when I set it and show my homework, use your revision guides. If you haven't got your revision guides, use the BBC bite-size link that I've given you guys. Make the notes from there on GPE. Do the questions on the bite-size, obviously, but also from your Caboodle textbook. It's on page 10 and 11 today on in your blue Caboodle online textbook. If you can't remember your login details, use Show My Homework. You can contact me through Show My Homework and I can give you your login details through that if you can't get access to your Caboodle login details. So, gravitational potential energy, let's start off with our recall quiz, what I'd like to call high five. You get all 5 right, you get a virtual high five from me. Number 1, what is the unit of energy? Question 2. What are the 2 major categories of energy? Two forms of energy or 2 types of energy. Question 3. What is the law of the conservation of energy? So some of these we've had on the previous lessons. Right, number 4. Work done. This was our last lesson. Work done equals something, something. You tell me what work done equals. You have to memorize your formulae, all your equations. You need to know them. Question 5. Work done equals, right, so these last 2 questions, one is what is work done, so it has equals, work done is something, something, and then the formula for work done, how do you calculate work done? Press pause, check your answers, make sure you got a thorough answer for all of these, and we'll go through them now. So the unit of energy is a joule, capital J O U L E, joule. Number 2, 2 types of energy, 2 forms of energy is your energy stores and energy transfers. And we can't get those 2 confused. So energy stores and energy transfer. Remember a bit of confusion between thermal energy and heat energy? Well, thermal energy is a store, but heating effect is a transfer, which sounds a bit confusing because it sounds like the same thing. But a store is where it's at in the system, a transfer when it goes from one store to another store. The law of the conservation of energy. Energy cannot be created, nor can it be destroyed. It can just transfer from one form to another. Work done equals energy transferred. Energy transferred equals work done. And the last one, the formula, work done equals force times distance moved. Force times distance moved. Right, if you got all 5 right, fantastic. You get a virtual high five from me. So, quickly, well, if you're by yourself, you can't discuss this, but have a think about, if you're on your own, if you're with somebody else, have a little chat. If you got 2 flower pots, one's on the top floor, one's on the ground floor. If both flower pots were to fall out of the window, which one is more likely to break and why? I'll pause the video. You want to pause the video, have a think about it, and then we'll come back to it. So, if you've had a chat about it or a think about it, which one is going to more likely to break, or which one's going to smash into more pieces? Well, it's going to be, it sounds obvious, the one from the top floor should smash with greater force as it impacts the floor and breaks into smaller pieces. But why? Why is the flat part at the top? Well, right at the top, the higher you take it up, the more gravitational potential energy store it has. And as it falls, it's going to gain kinetic energy. Why? Because it's going to accelerate. So its velocity will get faster and faster and faster. And if the velocity is coming faster and faster and faster, as it hits the floor, it's going to hit with a greater impact force and therefore smash. Okay, so that should be straightforward. It should be quite a straightforward thing. Now, what is GPE then? So gravitational potential energy is the amount of energy something stores depending on how high it is. So when you lift an object up, energy is transferred from your muscles into GPE, gravitational potential energy, of that object, like that weightlifter there. So gravitational potential energy, GPE, is the energy stored in an object because of its position in the Earth's gravitational field. So depending on which planet you're on, if you looked at one of my other previous lessons on W equals mg, the weight of an object will depend on the gravitational field strength. So it'll be obviously different depending on which planet you're on. So what do you think GPE would depend on? Well, it's going to depend on the amount of GPE depends on three things. What do you think those three things are? Well, the first one is its mass, how much mass it has in kilograms. The next is its height above the ground, how high it is above the ground. And the last thing is its gravitational field strength. So you might want to write this equation down. You need to memorize this equation, just like our previous lesson where you had to memorize work done is force times distance. This time, GPE equals mgh. Now with my lessons and my classes, it sounds really daft, but if you make it into some kind of rhyme and make a rhythm out of it or make it sound daft or anything like that, it will more likely stick in your memory. Because if you can do it by rote fashion, repeat, 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 repeat. If that doesn't work, make it sound stupid or make it have some kind of funny thing in your head or visualize it somehow, because you need to memorize it. If you look in the back of your caboodle textbook or even your revision guide, you'll see there's a whole list of physics equations that you have to memorize. Not just for your science, you've got a whole list of maths formulae you need to memorize too. So and then for your English, you got all those quotes and things. So there's so many things you need to memorize and commit to memory. And you can't do that unless you do it by rote fashion, hard work, graft, commit to memory by going over it and over and over again. And one thing to let things stick into your memory is to make it sound stupid. So turn it into a stupid type of rap or something like that. So GPE equals, I didn't hear you, GPE equals mgh. GPE equals mgh. So GPE equals mgh. The mass times the gravitational field strength times the height. So what was that again? GPE equals, yes, you're right, mgh. So GPE equals mgh. So the mass has to be in kilograms. So if you got something that's 500 grams, you need to convert it into kgs, into kilograms. So if it's 500 grams, it'd be 0.5 kilograms. G is the gravitational field strength. That's basically the pull of the planet on the object. And H is the height. So gravitational field strength is newtons per kilogram. And your height has to be meters. So if you've got something only 50 centimeters off the ground, that's going to have to be 0.5 meters. You have to convert it. Now, you need to memorize that then. GPE equals mgh. Now, you can do it as a triangle, formula triangle. So the GPE goes on the top, and you got mgh. Now, here's the thing. If you looked at one of my previous lessons on weight, your weight is actually mass times the gravitational field strength. So you could substitute that bit there by just putting in the weight. Because if you know the weight, now remember your weight is a force, so that's measured in newtons. So that bit there, W, would be these two numbers stuck together, times together. So mass times gravity is the weight. So GPE can also be the weight times the height. So it's the weight times the height. That's the simpler one. So if you look in your caboodle textbook, you'll see there's both formulae. On the left-hand side page, it'll say the weight times the height. And on the right hand side, it'll say mgh, the mass times the gravitational field strength times the height. So that's it pretty much for this lesson. We're going to try some questions out and see how we get this done. So remember, GPE equals mgh, and the triangle will look like this: GP at the top and then mgh. So if you wanted to calculate any of the other ones, if you covered it up, you'd have to multiply those two and then divide the top one by the bottom one. So if, for instance, in the question, if you have to work out the mass, I'd cover this up, I'd times those two together, and I'll do the GPE divided by those two times together. If I had to work out that one, I'd cover this up, I'd times that and that together, and I'd divide the GPE by that. If I wanted to work out the height, I'd cover this up, I'll times those two guys together, that divided by that will give you the height, because you can put it into a formula triangle. So let's have a go at some questions then. GPE equals mgh. GPE equals mgh. So you got calculate the GPE when you got 1,000 kilogram aeroplane. Now obviously it's going to be a lot more than that. These numbers are just to make things more simple. 1,000 kilograms is the size of an average size car or a small car. An aeroplane will be a lot more than that. It takes off to a height of 500 meters. Now, gravitational field strength on Earth is given it as 10 newtons per kilogram. We round it up if you just want to use a simple number. If you're not given the number, you just have to assume it's 10. But most of the time, the question will give you in the exam the number to use. So a more accurate number will be 9.81 or just 9.8. But just to make the numbers easy, we'll use 10. So I'm trying to work out the GPE. So what numbers do I need? I need the mass. Where's my mass? There it is, 1,000. Where's the gravitational field strength? There it is, 10. So it's 1,000 times 10. Where's the height? There you go, 500. So it's literally in the question, the numbers are there. Circle them, multiply them out, stick into your calculator, and you should get 1,000 times, I've got the change in height, swapped them around, times the gravity. It gives you 5 million joules. 5 million joules. There should be a capital J there. And I can remember from my previous video, I can take the zeros away because I can make that 5,000 kilojoules, or I can make it into 5 MJs. No, not 5 Michael Jacksons, 5 megajoules. Right, so here's some questions for you guys. Have a go at those 3 questions. That's just an extension task if you want to make up your own question. Have a go at those 3 questions and we'll come back to it in a second. So press pause, have a go at those questions, and we'll do the calculations. Okay, so if you've had a go at those, let's have a see if we got those right. So I've just swapped the mgh, I've just swapped the g and the h around just so that you can see that the g is going to be 10 for all of these particular questions. So GPE equals mgh, yep, that's right, GPE equals mgh. So if Maria lifts a mass of 10 kilograms on a table 1.25 meters high, how much GPE has the mass gained? So GPE equals mgh. So the mass is 10. So I'm going to get my calculator. I got my 10. I'm going to times it by g, which is 10. So 10 times 10 is 100. And then I'm going to times it by the height, 1.25. 1.25. And if you put that into your calculator, it's 100 times 1.25, which gives you 125, well, 125 what? Well, it's a form of energy. So GPE is energy, so gravitational potential energy, so it's going to be in joules. So you've got 125 joules of energy. Question 2, if Sophie climbs a ladder of 3.4 meters tall and Sophie has a mass of 48 kilograms, how much GPE has she gained? Well, that's a straightforward one. Again, the mass is 48. So get my calculator. 48 is a mass. Her gravitational field strength is 10. So we'll times it by 10 because that's her weight. So she actually weighs 480 newtons because her mass is 48 kilograms. And then we'll times it by her height. So she's gone up 3.4 meters. So times it by 3.4. And the answer is 1,632. So 1,632. I don't know if you can see that, but don't take my word for it. It's 1,632 joules of energy, or 1.632 kilojoules. Last question then to finish off today. Man of a mass of 80 kilograms, standing on top of a tall building, and he's got the GPE of 9,600 joules. How tall was the building? So we're going to have to assume that this building, well, it's not going to be on the moon, but this is going to be on Earth. So we're going to use the G of 10 in this question. So if the G is 10, and we want to know how tall it is, well, remember, if I cover up the height, right, so if I cover up the height, it's going to be that divided by those two guys times together. So if I was going to write it as one particular formula, you could just times those two guys together and then get that number and divide it, which actually is quite straightforward because his mass is 80 and it's going to times it by 10, which is obviously 800. So that number is 800. Now some people like to put the equation into a calculator straight away. So you need to really understand how your calculator works. So my 9,600, so I've got my 9,600 joules and I'm going to divide it by 800. But how would I do it straight off into a calculator rather than divide by 800? I'll press divide by, I'll have to press open bracket and I'm going to do my 80, my mass, times my 10, and then I need to close the bracket. So in my calculator I've typed in 9,600, oh wait a second, I made a mistake there, it's 96,000, not 9,600. So I need to read. Maybe I should get my glasses back because I haven't worn my glasses since we've been off. I think my eyesight's getting worse. Maybe the glasses need to come back. So 96,000 joules divided by, open bracket, 80, which is there, times by 10, which is up there. Then you close the bracket and then that will give me a final answer of 120. 120 what? Well, it's going to be 120 meters because we're going high. It says how tall is the building. So the really tall building, you've gone up 120 meters high. The next one then, it says how much GPE would you have in the same building were on the moon? Obviously there's not buildings on the moon, there's nothing on the moon, all right? No cheese, nothing, there's nothing on the moon, just boulders and big craters and stuff, but there's no buildings. But if there was a building on the moon, then remember the G on the moon is a lot less because you weigh 6 times less on the moon because the moon is 6 times smaller than the Earth. So the G on the moon is 1.6. So if I did the same equation for the moon, I'll do the same thing. So my 96,000, 96 with 3 zeros, divided by, then you have to press open bracket, because I'm going to multiply my mass times, my G is not 10 now because I'm on the moon, so it's 1.6. So it's 80 for the mass, times by 1.6 for my gravitational field strength, 1.6. I'm going to close the bracket and then I'm going to press equal. So in my calculator it reads 96,000 divided by, open bracket, 80 times 1.6, close bracket. Then I press the equals button and I get 750. So you can see that this building would be, if it was the same system, this building would be 750 meters high. If you had to walk up, it would have to be a much taller building to get the same amount of gravitational potential energy. But in this question, it's asking you to work out the GPE. So the GPE then, what would the GPE be on the moon if the gravity is a lot less? So we know that the building was, what was it, 700 and, what was the height of the building? Forgot to write it down. So we got, let's work out the height of the building, because we got the height of the building from the previous question. It was 120 meters high. So it was 120 meters high. Let's just double check again. 96,000 divided by 800. 120 meters, right? So the building was 120 meters high. So I've got my height, which is 120. I've got the mass. The mass doesn't change no matter where you are. So it's going to be, the GPE is going to be 80 times 120 times my 1.6. So the GPE will be 15,360. So 15 15360. So 15,360. So on Earth, the amount of energy or work done, or the gravitational potential energy you've gained, is 96,000. If you're on the moon and did exactly the same trip up to the same height of that building, 120 meters, then you'd gain 15,360. So a lot less gravitational potential energy stored in you if you go to the same height on the moon. Why? Your mass is the same, the height is the same, but the gravitational field strength is different. Now, if I times that number by 6, yeah, it gives me approximately, 92,160. So it's approximately right. So it's about 6 times less. So you gain about 6 times less GPE if you're on the moon. Okay, so that's what gravitational potential energy store is, how we calculate it. How confident are you? How confident do you feel? Can you identify what GPE depends on? Well, it depends on the mass, the gravitational field strength, and the height. And can you calculate it? Can you do some calculations? Are you confident? Are you okay? Are you not very confident at all? You can get back to me on Show My Homework if there's any issues, but make sure you do the work from the Bite Size website that I put the link on Show My Homework. You use your revision guide and make your notes from that. Use your Caboodle textbook, it's page 10 and 11 in your Caboodle textbook, and do the questions, write the key points out and do the questions from there. Any issues, you can contact me through either the YouTube channel, or you can contact me through Show My Homework. I hope this has been useful for you and you've learned something about GPE. So please like the videos, watch the videos, subscribe and share. And take care, and I'll see you next time.